So we are looking at problem 14, chapter 6, another centroid problem. This problem's got a lot of symmetry, particularly in this direction here. It's composed of a plate that is 14. Let's change that a little bit, which is 14 by 3/4 of an inch thick. And we have a channel here and a channel here. Those channels are both C 12 by 25s. So we're going to have to use the Appendix A for that again. Our origin is indicated to be over here. And what I've got here are some of the key numbers that we're going to need. This dimension here, which would be the depth of this. We're going to need to know the centroid location from the back edge out. So that will be the, I believe it's the bar X distance on our chart. And notice since they're mirror imaged, they just will be the same numbers. The x-axis will be coming this way, the y-axis will be coming this way. So we also need to define parts that we're going to deal with. So we'll call the plate 1. And we'll call this 2. And we'll call this 3 over here so that we know what we're talking about. Okay, so we need to go get some information. So we are dealing with a 12 by 25. So as far as that's concerned, we're dealing with the 12 by 25. And we need the area of that. And notice we need the depth. Depth is critical on this, so that's a depth value here. So that's exactly 12. So notice on the channel, the 12 is referencing 12 in this case, and it's exact, which is not always true in an I-beam. So they change a little. The other thing we said that we would need for the 25 is coming over here to the y-axis for the x-bar. So we need that x-bar value, that 0.674. So I believe that's everything we're going to need. So let's go back to our picture. And this is exactly 12 right here. So that's 12 inches. And this is 0.674 inches and 0.67. Oops, let's back that off. 74. So those are the distances from the back edge to the centroidal, what they're calling the y-axis, and it's actually the x-bar in this example for that thing. So let's go ahead, we'll set up our chart. So we're going to have shape, we're going to have the area, we're going to have the x value, ax, the y value, and the AY. Okay, so shape 1 has an area of 14 by 3/4. That will give us 10.5 square inches. So x is the distance from the origin to his centroidal y-axis. That would just be half of 14. So in this case, that's going to be 7. 7 times 10.5 yields 73.5. Y is the distance from the origin up to the centroidal axis of this guy, the XX axis. So that would be the Y distance. So that's going to be 12 plus half of 3/4. So that's going to give us 12.375, to which we will multiply the area by. And that gets me 129.938. Okay, so looking at shape 2 now, shape 2 is that channel. And if you remember what we had for that, 7.34, that's my area. So let's go back to that, 7.34 is my area. So X is the distance from the origin to the centroidal YY axis of this guy, which is this one that we were able to look up. So that's a nice, easy lookup. We're going to multiply that by the 7.34. So ultimately that gets us 4.947. The Y value in this guy is just half of the depth, so that's 12, so this becomes 6. 6 times the area gets us 44.04. Okay, so shape 3, it's mirror imaged essentially, so the area is going to be the same part. The X is going to be the distance from here to here, so we're going to take 14 minus 0.674, so again 14 is the total distance, minus 6.74, so that gets us a value of 13.326, to which we will multiply the area, which gives us 97.813. Okay, so this guy will have the same value Y, so it's half of 12 again, that's going to be 6. 6 times that's going to yield for us the 44.04 value. So we can sum our area, sum our AXs, and sum our AYs. So for my area, we have 25.18. For the AX, we have 176.26. For the AY, we have 218.018. So X bar, sum of the AXs divided by the sum of the areas gives us 7. So it's exactly 7, and Y is going to be the sum of the AYs divided by the sum of the area. Gives us 8.658 inches, which you could probably round to just 866. So let's look at this when we come over here. If we look at this now, because of the symmetry that's going on, we know that this guy is my line of symmetry, right? Oops, let me undo that. Let's turn this on. It makes it a little easier to draw the straight lines. So here's our line of symmetry, and here's our other line. So what we've got going on there, don't want that on, is this is like this. Okay, so that gives me, this is my X bar distance. Let me clean up this down here. And as you can see, this would exactly be half the distance. So the other one is coming in a bit higher, if we notice what's going on. So 6 would be about right there. So we're somewhere about right in here for that. Oops. And this distance then here would be my Y bar, the 8.66. So my centroid is somewhere right here about, okay? So as this plate would get thicker, that would push this guy up. If we added another plate of equal value at the bottom, then it would be right in the center in both directions. So you should start to get a little sense for how this works. And a lot of times in these types of shapes, you do have a lot of symmetry going on in one axis or the other. So always be on the lookout for that. Particularly, we're going to see the same thing as we get into moment of inertia, which will be the next thing we'll be talking about in chapter 7.